Hey there, it's Jason Gorman from Codemanship with a video about simple design in Java. The principles of simple design are a set of 4 design goals, courtesy of our friend Kent Beck, that we can apply to our code as it's evolving, for example, as we're test driving and fleshing out a design. So at every step in the process, we sit back and we review our design and we ask these questions and refactor the code if necessary. And you'd be surprised how elegant sometimes the designs that emerge from this can be, these very simple principles. It's a hierarchy of design goals, and the most important goal of any software design is that it must work. In other words, it passes its tests. And that's why tests are so important for keeping our code working. So make sure that it works. That's the most important thing. It doesn't matter how elegant or clean or interesting or clever your design is. If it doesn't work, then it's the wrong design. Provided that it works, the next thing that we worry about is whether the code clearly communicates its intent. In other words, we can understand what the code is doing just by reading the code. The code tells its own story. And that's a whole discipline there about communicating through code. So we make sure it works, we make sure that it's easy to understand, that it clearly communicates its intent, and then we look for duplication for 2 reasons. Number one, when we duplicate logic in our code, if we need to make a change to the common logic, we've just duplicated the cost of making that change, so it increases the cost of maintaining code. But also from a design point of view, duplication is very interesting because the opposite of duplication is reuse. So as we remove the duplication from our code, that's often where the abstractions and the modularity come in, the reusable elements come in. So we kind of discover reuse rather than planning for it, which is a much more evidence-based, a much more scientific way of designing modular software, is to discover the need for reusable elements like parameterized methods and reusable classes rather than planning them up front. The danger here, of course, is that we go too far and we make our code so modular that nobody can understand it. So how easy the code is to understand always beats being low in duplication. So once you've removed the duplication, stop and review the code and ask yourself, has that actually made it harder to understand? And if the answer is yes, maybe put the duplication back. So not always the case that we'd remove duplication, but very often when we do, we end up with something that is very interesting. And those principles, the second and the third, often work together. The reason why when we sort of introduce modularity, when we compose software out of these smaller reusable parts, that programmers can find that code harder to understand is because we've chosen bad names for those reusable elements. They don't clearly describe what those elements do. So you find yourself having to jump around in the code, looking inside these methods and classes to understand what they do. So these 2 principles can kind of help each other here. The key to writing software out of that's composed out of these small reusable elements is to choose good names, names that clearly communicate what these elements are doing. And finally, from which simple design gets its name, we make sure that what we're doing in our code, what we're doing in our design, is the simplest thing we need to do to pass the tests. That there are no unnecessary elements in there, the smallest number of elements, if you like. And the rule of thumb here is Y.A.G.N.I, you ain't going to need it. And I find that developers really struggle with this. For often when we're writing code, we're adding elements just almost sometimes out of habit or convention that are totally unnecessary to actually passing the test. They're not the simplest thing we could have done. So be brutal with yourself, be honest with yourself here and ask, did I really need that? Did I really need that database? Do I really need logging? Do I really need to use the strategy pattern? Or am I just speculating about what I think I might need, or just following a convention like, oh, well, we always have a business layer and a data layer and a controller layer. But do what you need to do, the simplest thing possible to pass the tests, and let the design emerge organically from passing tests rather than in a kind of forced way from adding elements that you think belong there, but we don't really need to pass those tests. So those are the 4 principles of simple design. Make sure it works and that it stays working. Whenever we change the code, we need to get back to passing tests as quickly as we can. Make sure that our code clearly communicates its intent. It tells its own story, if you like. So choose names very carefully to tell that story. Look for duplication in your code and remove it, provided that it doesn't make the code harder to understand. And choosing good names here really helps. And that's where a lot of the modularity and the reuse comes from in our code. It's where some of the best designs come from. And finally, make sure that what you're doing really is all you need to do to pass those tests, that we're not speculating or adding elements or gold plating it in some way that we don't need to do. So you need to be brutally honest with yourself. Now, let's look at a little example to illustrate these principles. So I've got some code for a Mars rover here. This is an exercise that we've covered in other videos. Just to briefly explain what this code does, it drives a Mars rover over an idealized grid of XY coordinates that represent the surface of Mars. And we can send it sequences of instructions that contain individual characters: R to make it turn to the right, L to make it turn to the left, F to make it go forward 1 square, B to make it go backwards 1 square. And I've got this working now, so let's just make sure, number one, that we're ticking that first box, that first principle of simple design. Let's run the tests and make sure that it works. Off it goes. Super duper. All our tests are passing. Looking good now. Now that we know that it works, let's move on and think about how easy it is to understand this code. Does this code clearly communicate what it's doing? For example, what is this block of code here doing? I'm not at all convinced that it's doing anything particularly useful. Maybe what we can do here is we can essentially describe what this code does by extracting into a method and using the name of the method to say that's what this block of code here is doing. So let's extract a method. So what does it do? Well, it turns it to the right. So that's the code that makes the rover go right. Okay. And as soon as I've done that refactoring, I need to get back to working code, make sure that it works straight away. Whatever our design is, make sure that it works and stays working. Great. Okay, now how about this block of code that looks very, very similar? Now this is actually turning it to the left. So let's extract a method that turns the rover to the left. Okay. So now the code is beginning to describe what it's doing. We're starting to tell the story using the code itself. So particularly when you see comments in code, look for opportunities to incorporate those comments into the names of things like methods and classes and variables and constants, so that the code can tell that story as much as possible. 90% of the time, I would say, it is possible to make the code describe itself. It's quite rare that you actually really need a comment, for example. Now this moves the rover 1 square forward. And see how I'm always going back to making sure that it works. Whatever the design is, however sophisticated or clever I think it is, however readable, however free of duplication, however simple, needs to work. And this moves the rover back. Okay. So now we've introduced those words into the code: right, left, forward, back, by extracting methods that tell that story. So our code is becoming more self-describing. So now we're taking care of the second of the principles of simple design. That code is beginning to clearly communicate its intent. Let's think a little bit about the third principle, duplication. Our back and forward methods, for example, very, very, very similar, very similar. And our left and right methods, again, very similar. Let's start with left and right. They're nice and simple. So what's actually happening here? The bits that these two lines of code here are identical. So let's extract these into their own method. I'm pretty sure I can see what's going on here. So this is turning the rover in whatever direction, in whatever orientation of the compass we tell it to. So whether it's clockwise or anti-clockwise. So let's turn that. Okay. And IntelliJ is smart enough to recognize that there's some exact duplicate code there. So let's replace that. And immediately back to code that works. Right, now, we can make this a bit more describing. These compasses, we can tell more of a story here. For example, let's inline this. And we're also going to inline that one in a minute after our tests have run. Super disciplined and getting back to working code as quickly as possible. Okay, now, turn northwest, southeast, turn northeast, southwest. We could make that a bit more self-describing while we're here. So the trick when we're removing duplication and we're introducing abstractions like this is to look for opportunities to make them tell their own story so that we don't need to look inside to go, well, what's it doing with that? So how about we introduce a constant, and let's call this, for turning left, it's anti-clockwise. With an S, because I am English. Okay. So we've used a constant there to essentially name, what does that mean when it's north, northwest, southeast? And down here at the bottom, again, we can say, well, that's clockwise. So let's move this out of the way. There we go. So turning left, turning right, clockwise and anti-clockwise. All good stuff. Now, how about our forward and back? Again, they're doing something very, very similar here. And when I see that kind of similarity, sometimes what I want to do is make them somehow exactly the same, apart from one thing, which will become a parameter for a new method. So the minus and the plus here, what I'm going to do is a little bit of mathematical trickery here. -1, oops, times our vector. So a little bit of trickery here. Okay, and you'll see why I've done that in a minute. Let's just rerun our tests. Now what I'm going to do is I'm going to extract all of this code here into a method called turn. Well, not turn, move. My plan here is that I'm going to introduce the concept of direction. So we're moving in a particular direction. And what I've just done there, we're introducing that -1, is introduce a variable which is going to become a parameter of this method, which represents the direction that we're moving in. So let's introduce that as a parameter. And we'll introduce it there as well. Okay. And you'll see that there's a kind of a method to the madness here, because what I'm going to do for my forward method is reuse turn with a positive direction. It's -1 if we're going backwards. Not turn, move. I'm getting those mixed up again. So +1 is move forward, -1 is move back, whichever way we're facing. Okay, and now this +1, this -1, let's move this turn method, this move method, still mixing it up. Move method, let's move it out of the way for a second so that forward and back are together, so hopefully it'll be a little easier to see. Keep it working. Principle number 1, if it doesn't work, then it's the wrong design. Okay, so there, forward and back. We can make this a bit more explicit again with constants. These are magic numbers, if you like. So let's introduce a constant. Forward. And introduce a constant here. Back. And now, as we sort of look at this, forward, back, and etc., etc., I'm thinking here maybe turn clockwise. Is that better or worse, do you think? Is that easier to understand than right? I'm not sure about this. Let's keep going. Keep running those tests. I'm going to inline that. See, I think clockwise, anti-clockwise, I think maybe what we can do here to make this more obvious is just that. Turn right. So you must be constantly reviewing your code. Is it easy to read? Is there duplication in the code? Is that really the simplest thing we could have done? And of course, you must be constantly running your tests to make sure that at every stage, your code is working. And I think we can get away with a similar thing here. We don't need these methods anymore, I think, for left and right and forward and back, because I think we've got enough here to tell the story. And I don't think these methods are adding any value. So let's get rid of them. That's going to unclutter our code. It's still pretty self-documenting, I think. It's pretty obvious what's going on there. If instruction equals R, turn right. If instruction equals L, turn left. Instruction equals F, move forward. If instruction equals B, move back. So there you go. We've made sure that our code is working at every stage. We've made the code much more self-describing, hopefully, and we've also removed some duplication from the code. So there's less code now that needs to be maintained. There's probably more work to do on this in that respect, but I think this is a definite improvement. For a start, there's a lot less code, but also I think it is much more self-describing now. There's a lot less duplication in our code. But there's still one principle we need to be thinking about, which is Y.A.G.N.I, you ain't going to need it. Is this really the simplest code we need to pass the test? And I don't think that it is. I think the offending code here is this. The tests will pass with or without logging. I have to say I am not a huge fan of logging for various reasons. One, because it clutters up the code, unless, of course, you're doing aspect-oriented programming, in which case there's a neat way out of that. So it clutters up the code. I've known many logging frameworks to be themselves a little unreliable. So quite often when you're finding bugs in your code, or when you're getting errors at runtime in production, you trace it back to the logger itself. So it's just more stuff that can go wrong. And therefore, in this instance, I don't think it's necessary. You'll see down here the logs that it's been producing. So we're running our test there, you see. And I don't find them particularly helpful. If I need something like that, I can always put in a print statement. So I'm going to get rid of this locking code. I don't think it does anything for us. I don't think it's doing anything to... Oops. Did not mean to do that. I don't think it's adding any value here at all. And I'm going to prove that by running the tests. So generally speaking, if you can remove code, for example, like that, and all your tests still pass, then maybe you didn't need that code. So Y.A.G.N.I, you ain't going to need it. And I'm just going to finish this off by removing some things that I no longer need. So there's a bunch of extra stuff that has to come with log4j, like this configuration file. So I don't think I need any of this. It's complete overkill for our Mars rover, so let's get rid of it. Now, of course, in other kinds of applications, you may need logging, but for our Mars rover, I don't think that we do. Okay, let's rebuild that and rerun it. Proof of the pudding, does it work? No, it doesn't work because I've got a bunch of unused imports there. Silly Jason. Okay, let's try it again. So there you go. That's the principles of simple design. First of all, and most importantly of all, make sure that it works. Provided that it works, that it's passing its tests, make sure that it's easy to understand, that the code clearly communicates what it's doing. It communicates its intent. Then remove duplication from your code, unless that makes it harder to understand. But these two principles kind of work together. When we're introducing reusable elements, we need to choose the names of those very carefully so that they do clearly communicate their intent. And when I work with, particularly with more less experienced developers, often they'll find that highly composed code that is composed of references to other reusable elements, tend to find that code harder to follow, because when they're writing highly composed code, they're maybe not quite as experienced at choosing good names, so you're having to jump all over the code to look inside these boxes to find out what they're doing. Whereas really the name of the box should describe that. It shouldn't be necessary to look inside the box in order to use its contents. And then finally, make sure that what you're doing really is the simplest thing that you could have done to pass those tests. So if you're finding the elements that are adding no value at all, for example, or if you're introducing what we call speculative generality or gold plating it, you need to take all of that stuff out. Is that really the simplest thing we could have done to pass the tests? So there you go, principles of simple design. And as you apply those principles over and over again, after each test, you will be surprised at the sort of the sophisticated designs that can emerge. As long as you're pretty rigorous about it and remember to do it on a pretty regular basis. You don't just leave it all till the end of the first week. You need to be doing it over and over and over again, and applying these simple rules over and over again. Complex, rich designs can emerge and will emerge, and in a way that's much more kind of evidence-based, that you're not thinking, I reckon I'm going to need one of these, or I reckon I'm going to need one of these. I reckon we should use Spring for this. You're actually discovering the need for these things, discovering the need for things that have names that describe what they do, discovering reusable elements like parameterized methods and reusable classes and so on and so forth. And very importantly, as we mercilessly remove unnecessary complexity from our designs, we end up something that is both easy to maintain and simple and easy to understand. Okay, the next video we're going to talk about the principles of modular design in Java, so look out for that. If you want to stay up to date with these videos, ring the bell for notifications, subscribe to this channel. If you have any feedback about this or any other videos, please leave that feedback in the comments below. See you in the next video.